This video is a quiz review for our next quiz that's going to cover everything we've looked at so far. Alright, those topics include the Pythagorean theorem, right, and that tells us if we know it's a right triangle, then we know we can use our formula a squared plus b squared equals c squared, right? So we can find missing sides if we know it's a right triangle. The converse to the Pythagorean theorem tells us the opposite. If I know a, b, and c and I plug it in, and a squared plus b squared equals c squared, then I know it's a right triangle. Right? So Pythagorean theorem, if I know it's a right triangle, I can plug it in and find missing sides. The converse tells me if I know the sides, I can plug them in to see if it's a right triangle. Now, it's not always going to be a right triangle, which is where our Pythagorean inequality theorem comes in. If c squared ends up being bigger, greater than a squared plus b squared, that tells me that the triangle is obtuse. If c squared is smaller than a squared plus b squared, if it's less than, that tells me that the triangle is acute. Right? So we've got all these ways of figuring out how to classify our triangle by its angles. Right? We've also got the special right triangles. We have two special right triangles. Okay? One is a 45, 45, 90, where we have two congruent sides. So we have an isosceles right triangle. So we have 45, 45, 90. If our legs are 1, that makes our hypotenuse the square root of 2. So to go from a leg to hypotenuse, we multiply by square root of 2. To go from hypotenuse to leg, we divide by the square root of 2. Our second special right triangle is 30, 60, 90. Right, so we've got 30, 60, 90. Okay, so we have a short leg, which is opposite the 30, a long leg, which is opposite the 60, and our hypotenuse, which is opposite the right angle. Okay, if our short leg is 1, to get from short to long, we multiply by the square root of 3. To get from short to hypotenuse, we multiply by 2. The thing to keep in mind with a 30, 60, 90 is you have to know the short leg to get to the hypotenuse and the long leg. Right, so if you're not given the short leg, that's the first thing you need to find. And the last thing that's going to be on this quiz is right triangle trigonometry, right, which we will put down in this corner. Okay, we got to remember SOHCAHTOA. We've got sine, cosine, and tangent, right? So that's just writing our ratios, right? So for example, if I have a, b, c, little a, little b, little c, and I want to find the sine of a, opposite a is little a, right? And the hypotenuse is little b. So the sine of a would be whatever little a was divided by little b. Right? So we're going to classify these triangles as right, obtuse, or acute. So we're going to have to plug in our a, b, and c, and make sure, or see where it fits, if c squared is the same, bigger, or smaller. Before we do anything, we have to make sure it is a triangle. Alright, so that goes back to the last unit where we use our triangle inequality theorem. So I'm going to see if the sum of the two sides is greater than the third. So this is 12 and 14 is greater than 20. 12 and 20 is greater than 14. And 14 and 20 is greater than 12. So this is a triangle. Right? 4 and 7 equals 11. That's not greater than, so this one right off the bat we know is not a triangle. 9 and 12 is greater than 15. 9 and 15 is greater than 12. And 12 and 15 is greater than 9. 10 and 24 is greater than 10 root 6. Right? If you think about 10 root 6, it's going to give you somewhere around 24 and some change. Right? A little over 24. 24 and 10 root 6 is greater than 10. And 10 and 10 root 6 would be greater than 24. Right? So those three are triangles. So we come back to this first one. The only thing that matters is that my largest side is C. So in this case, I can do 12 squared plus 14 squared, and I want to see how that relates to 20 squared. Well, 12 squared is 144, 14 squared is 196, and 20 squared is 400. Right? 144 and 196 gives me 340. 340 is less than 400. So my c squared is bigger than a squared plus b squared. So this triangle is obtuse. Right? Looking at 9, 12, and 15. We got 15's got to be c. So 9 squared plus 12 squared. We want to see how that relates to 15 squared. So 9 squared is 81. 12 squared is 144. 15 squared is 225. 81 and 144 gives me 225, which is equal to 225, so this is a right triangle. Now you may have noticed that 9, 12, and 15 is one of our triples, 3, 4, 5, everything multiplied by 3. So if you recognize that, you wouldn't even have to go through this. You could automatically know it's a right triangle. Right? In our last one, we got 10, 24, and 10 root 6. 10 root 6 is our biggest side. So I've got 10 squared plus 24 squared. And we see how that relates to 10 root 6 squared. 10 squared is 100. 24 squared is 576. Right? And to square 10 root 6, right, I distribute. So I end up with 100 times 6, which is 600. So that leaves me with 676, 600. 676 is greater. So my c squared is smaller, which makes this triangle acute. Right? And for this one, we're just going to find the missing sides. One important thing that you have to remember is you have to be able to differentiate between when to use trig and when to use your special right triangle rules. Right? So if we look at this first one, I'm given one side and an angle that's 52 degrees. Well, 52 isn't one of our special right triangles, and I'm only given an angle and a side. So I'm going to have to use trig, right? I'm trying to find both of these, so if I call BCX and ACY, right? If I want to find y first, and I look at 12 and y, well, 12 is opposite 52, and y is my hypotenuse because it's opposite the right angle. The trig function that uses opposite and hypotenuse is sine. So I can say sine of 52 equals opposite 12 over hypotenuse y. So to solve for y, first I multiply to get it out of the denominator. So I have y times sine of 52 equals 12. Divide by sine of 52. Right, that goes away. And remember, make sure your calculator is in degree mode. So y is 15.23. Right? Not done yet. Now I have to figure out my x over here. So I can go ahead and plug in 15.23 here. Okay, so to find x, technically now I have two sides. So I could go ahead and say Pythagorean theorem, x squared plus 12 squared equals 15.23 squared. Or I could even do a trig function using my new hypotenuse, but that wouldn't necessarily be as accurate because 15.23 is rounded. So I'm going to choose to use the 12 that I have that's not rounded and use a trig function to find x. So again, this 12 is opposite the 52, and this x is adjacent. So opposite and adjacent would give me tangent. So I could say the tangent of 52 equals opposite 12 over adjacent x. Just like before, I've got to get that x out of the denominator. So x times tan of 52 equals 12. Divide by tan of 52. So we get x equals 9.38. Alright, so 9.38. Alright, for this middle one, I've got 43, 56, and I'm trying to find this third side over here. I don't have any angles, so I'm going to use the Pythagorean theorem. Right, so I know that 56 is my hypotenuse. It's across from the right angle. So if I call this side P, say P squared plus 43 squared has got to equal 56 squared. So P squared and 43 squared is 1849. 56 squared is 3136. subtract 1849. So we get p squared is, do my calculations, 1287. Right, 1287. So to solve for p, I gotta take the square root. Right, if I plug this in, I'm gonna get an ugly decimal, so I gotta try and simplify. Right, 1 plus 2 plus 8 plus 7 gives me 18. Right, so this means it's divisible by 3. So I've got 3 and 429. Right, 4, 2, and 9 gives me 15, so I know it's divisible by 3 again. Right, so I've got 3 and 143. Right, and then just because I've seen this number before, I know that 11 goes into it, and 11 times 13 equals 143. So I've got a group of 3's I can pull out. Right, so I've got 3 times the square root of 143, 11 times 13. Right, so my missing side over here, p, is 3 root 143. Right, the last one, we've got a side here, 32, and an angle, 45, and I'm trying to find, let's see, we'll call this A and B. Right, I'm trying to find A and B. Now, normally, like this first one, I had an angle of 52 and a side of 12, so I used the trig function. I could do that here, but I have a 45, 45, 90 triangle, so I don't have to. Right, I have my special right triangle rules, and I can give an exact answer here as opposed to trying to plug it in and get a decimal. So 45, 45, 90 means that both of my legs are the same. So if this one's 32, that means A has to be 32. And to go from a side to a hypotenuse, I multiply by root 2. So this gives me 32 times the square root of 2. And that one's done. Okay, so make sure you can tell the difference and look for whether you need to use a trig function or just a Pythagorean theorem, or if it's a special right triangle and you can apply your rules. If you're okay with everything you've seen on this video, you should be pretty good for your quiz coming.